process of glycolysis, so pay attention. Okay, so to start the process of glycolysis, we need a 6-carbon molecule, also known as glucose. And to further go into this process, we need 2 ATP, also considered energy, to act upon our glucose, which will then split it into 2 3-carbon molecules, also known as pyruvate. So once we get there, from this interaction of ATP breaking our glucose into pyruvate, we get 2 hydrogen molecules on each side. So for each pyruvate, we get 2 hydrogens, and what these hydrogens are going to attach to is what is called NAD. And so when the hydrogens attach to NAD, it is going to form what is called NADH. So, and then once NADH is formed, that is going to be a product that is counted, a final product counted in glycolysis. And then what is made further down the line in glycolysis is going to be 2 ATP, but 2 ATP on the top, and then there's going to be 2 ATP on the bottom. So in total, we have 4 ATP, but the net gain is going to be 2 ATP because it required 2 ATP to make 4. And so in total, we have gained 2 pyruvate, 2 ATP, and that's a net gain, and then 2 NADH. Welcome back. Today we're going to be going through the process of the link reaction. This is the process that is the follow-up to glycolysis, and this happens in the matrix of a cell. So what we have here is our 2 3-carbon molecules, also known as pyruvate, and the first process in the link reaction, we have the NAD, for both of our pyruvates. And what this is going to do is it's going to take out a hydrogen from each of our carbon, or our 3-carbon molecules, and this is going to make the reduced version of NAD, also known as NADH. And also in this process, it makes a positively charged hydrogen, so an ion, a positively charged ion in this process, although these are not used later until the later process in the electron transport chain. So once these are gone, our hydrogens have moved on, and our protons we don't need. CO2 comes in, and CO2 is going to be taken out of each of our pyruvates, and so this is going to be an end product of our entire process. So we have 2 CO2s, and they are removed from our CO2, or they are removed from our pyruvate. So this leads to a reduction of a carbon in each pyruvate. And now that we have produced CO2, we can now move on to the enzyme enzyme CoA, and the attachment of it to our remaining 2 carbon molecules. So after we have produced a carbon from both pyruvates, we have an enzyme called enzyme CoA, and what this is going to do, it's going to attach to our 2 carbon molecules, and what this forms is acetyl-CoA.